Okay, hi guys, welcome. This is practical 3. We're going to be working with solubility and KSP. So I'm just going to go through some of the apparatus that we have here in front of us. So over here on our stand, we've got a burette and a pipette. We've got our indicator for the titration, phenolphthalein. We've got 2 funnels. You'll see why now. I've already pre-weighed exactly 2.00 grams of potassium bitartrate into this beaker. In this 250 ml beaker, we've got distilled water. We've got our 4 conical flasks or Erlenmeyer flasks for our titration. And we've got our 0.05 molar sodium hydroxide solution. Okay, so what we're going to do with this video is we're just going to go through experiment 1 of practical 3, where you do the titration in water. And then we will give you the values for the titrations with the different concentrations of potassium nitrate for you to work out the equation, the maths yourself later. Okay, so we're going to start, as I said, 2 grams of potassium bitartrate. I'm adding in 150 moles of water, distilled water, and we just have to stir for about 2 or 3 minutes to make sure that we have a saturated solution. Okay, so what we mean by saturated solution is that not all the potassium bitartrate is expected to dissolve in this water. So we know that the maximum amount or the maximum number of moles of potassium bitartrate is in the 150 milliliters of water. Okay, there we have our potassium bitartrate solution. Now we just have to wait for it to settle, so we give it about 5 minutes for it to settle, and then we will filter into our 250 ml Erlenmeyer flask. While it's settling, I'll so long explain to you guys how to fold the filter paper. So this is a filter paper. So one of the ways to fold it, there are numerous ways. So this is not just the only one, but fold it in half, and then we fold it in half again till you get about this semicircle. I like filtering into an Erlenmeyer flask just because the Erlenmeyer flask actually holds the funnel, so it's less for me to do. And then you're going to open the filter paper like this and place it into your funnel. Okay, so we've waited a few minutes for this solution to settle. So any excess potassium bitartrate will have settled to the bottom of this beaker. So when you do your filtering, you keep 2 hands on top of the filter paper so it doesn't pop out of the funnel like that. And you're going to just gently pour in your solution. Make sure that you don't pour it so that the solution comes up over the edge of the filter paper. Okay, so we wait for that to filter. It will take a few attempts, and then any leftover undissolved potassium bitartrate will be caught in the filter paper. I'll prepare our burette. So we are going to be putting our potassium bitartrate into 4 different Erlenmeyer flasks, and we're going to be titrating it with the 0.05 molar sodium hydroxide. So I quickly just want to show you guys how you prepare a burette. So this burette I've already rinsed out with distilled water. So any liquid in here is just distilled water. So what you usually do is you're going to add a small amount of the sodium hydroxide to your burette, like about 5 ml or so, making sure the tap's closed. Hold on this side, and we're just going to rinse the inside of the burette with the sodium hydroxide solution so that when we add our sodium hydroxide for the titration, it doesn't get dissolved by anything else that is in the burette. And just empty it into our waste beaker. and then we just clamp it and leave it there while it just rinses itself out. Okay, so while we're filtering, I'm just going to fill up the burette. It's always good practice to have a waste beaker under your burette just in case you haven't closed the tap, which does happen sometimes. We're going to use a plastic funnel so that if something happens, we don't break a glass funnel. So I'm going to fill the burette up. Okay, and let it run through. The reason we let it run through is for us to take an accurate volume reading. We have to also have this bottom part of the burette full with our sodium hydroxide. Okay, so always make sure before you start a titration that there's no air bubbles at the bottom here. Okay, I'm going to empty it now so that I can get to the 0 mol mark. So remember, area of parallax, always make sure that you are at eye level when you start. Okay, so I've started it at exactly 0.00 milliliters. That is not what it has to be at. As you'll see in your report sheets, you're going to write down the initial volume and you write down the final volume. So your initial volume doesn't have to necessarily be 0.00. I just got it lucky this time. Okay, so we've finished filtering a solution into our Erlenmeyer flasks. So we're just going to mouth pipette 25 ml aliquots of the solution into these 4 different conical flasks. Okay. So please bear in mind, in proper lab conditions, you will not be mouth pipetting. But in our first year practicals, we use very benign chemicals. So our potassium bitartrate is tartaric acid that you use for baking. So this is why we're allowed to mouth pipette. Okay. So I've got my filtered solution here. I'm going to put the pipette in. I need to keep my finger over it so that it blocks it. And I'm going to gently suck until it comes up to this calibration mark there. So that calibration mark there indicates that it is exactly 25 milliliters. So you overshoot the calibration mark and then just gently lift your finger so that you empty it until the bottom of the meniscus is on the calibration mark. So you overshoot the calibration mark and you empty it gently by releasing your finger until the bottom of the meniscus is on the calibration mark. There we go. And empty it into your conical flask. Okay, we can put that aside as well. Okay, so I've got my 4 conical flasks here. I've labeled them R1, 2, 3. So R is my rough titration, and then these 3 are going to be the values that we're going to use for our calculations. So before we start titrating, very important is to add your indicator in. So this is phenolphthalein. So we add 2 drops into each Erlenmeyer flask, about 2 drops. As you can see, there is no color change. So as the pH of the solution changes to within the indicating area of the indicator, we will see a gradual color change. So our end point that we're aiming for is a very pale pink end point. Okay, so not a nice bright pink color, very pale pink. So we're going to start with our rough titration first. over. So I've filled up my burette. I've got my conical flask under there. So the reason that we do a rough titration is to get an estimate of the volume that we need to get to the endpoints of our titration. So we don't want to start with an accurate titration because then we're going to go drop by drop and we don't know how much of the sodium hydroxide is required. So we may go through a whole 30 milliliters drop by drop, which will take a really long time. So when you start your titration on the report sheet, under rough titration, V-start, I started at 0.00 milliliters. Remember, burettes, pipettes, always to 2 decimal places. So as I open the tap, I stir with my left hand. So you can see as it's adding in, it's changing color, but then with the stirring, it dilutes again, so the color disappears. So we keep going until the entire solution is a pale pink color. And as we get closer to the end point, the longer it takes for the color to disappear. Okay, there we have our endpoint. So this one, because it's our rough, it's fine that we overshot the endpoint. So we can see we've got a very dark pink color. This is not what we're aiming for. But we at least have an idea now of the volume that's going to be required to do this titration. So I look up to get my final volume. So it is 11.50. So that's your V end is 11.50. Now we know that it takes approximately 11.5 milliliters to get to this endpoint, which is a little bit overshot. Just say in your titration that you start now at 11.50 milliliters. Okay, so we said we're going to go about 9 milliliters quickly, then we'll start going slowly. So let's add in our 9 milliliters. So that's going to take us to just over about 20.5, which is at that point over there. So I can do that nice and quickly. Okay, and we stop at 20.5. Okay, so we can see that we haven't got near the equivalence point yet. So now we need to start adding drop-wise. Okay, so now we add very carefully while we stir, watching the color. And we're looking for a pale pink color that persists even after we've stirred. So the previous one, you saw that it went very dark pink, but with a little bit of stirring, now it's gone colorless again. So we know we are incredibly close to the end point. So we want to add just one more drop of the sodium hydroxide. Okay, and you stir it a bit. You need to make sure that the pale pink color persists. Okay, we'll come back to that in a second. Okay, so we take our final volume. So I just have to move this up a little bit and look right there, and it is 23.10. So remember, with the burette, you're always measuring 0 milliliters from the top down to 50 milliliters at the bottom. You're effectively measuring the volume that you're dispensing out of the burette. Yeah. We move on to our second accurate one. So again, we're going to do 9 milliliters fairly quickly, and then we'll go drop by drop. So we're at 23 at the moment, so another 9 milliliters is going to take us down to 32. Okay, I've reached my 9 milliliter mark. So now we're going to go drop by drop until we see a persistent color change. Okay, so we swirl it for some time to make sure that the color doesn't perhaps fade. Okay, and we record our final volume, which is now, let me just move it up so I can see, 34.60. Okay, so you can see over time the color is getting a little bit paler. Okay, I'm going to top up my burette a little bit just for the last one to make sure that I don't run out of any of the sodium hydroxide. We know that that's going to be more than enough. So remember to take your initial volume reading. So on this one, we have 15.40. We can dispense 9 mils quite quickly, so that's going to take us to 24. Okay, and when we get there, we slow it down to drop by drop. Okay, and then we have our final titration. So as you can see, the color does fade over time. Okay, take our final volume reading. 26.90. Okay, so once we are done with the titrations, now we know the volumes that are required. So we do a quick calculation to work out the change in volume for these three to make sure that they are very similar to each other and within analytical limits, so that we can then determine the solubility of the potassium bitartrate. Okay guys, so you can see here how the color has changed over time. So here are our three that we're going to use for our calculations, and we can see that our rough titration is just a little bit darker. Okay, we're going to repeat this experiment with the potassium, 2 grams of potassium bitartrate, and instead of 150 milliliters of distilled water, we're going to use the various concentrations of potassium nitrate to see what difference that has with the values that we get. Remember, though, that our concentration of sodium hydroxide is also going to change, as is explained in the instruction sheet. Okay, guys, also remember that when you are doing your calculations for the average volume of sodium hydroxide that is used to titrate the potassium bitartrate, you only use the volumes that you get for your accurate titrations 1, 2, and 3, and you don't use the volume that you got in your rough titration. Okay.